Welcome students. In the previous class we have seen what is the arithmetic growth rate as well as the geometric growth rate. Here those were that is the growth rate can be we already know that growth rate can be measured and it can be mathematically expressed in the form of this graph, that is by plotting graphs, that is by arithmetic and geometric means, that is graphs here. Now we can also have quantitative comparisons between growth of living organisms. We can have quantitative comparison between growth of living organisms. Here mathematically we have seen how we can calculate the growth rate by arithmetic and geometric growth rates. Here in this class we will see how we can make comparison, quantitative comparison between growth of living organisms. We can make quantitative comparisons between growth of the living organisms. So how much growth was initial and after a period of time how much of growth has taken place can be measured. So here this quantitative growth can be measured in two ways. Quantitatively growth can be measured in two ways. One is absolute growth and the other is relative growth. By comparing quantitative comparisons, we can measure the growth of the living organisms by two ways. The first way is absolute growth and the second way is the relative growth. So absolute growth, how much, it is just simple, how much growth has taken place in a unit time. Absolute growth is very simple, in a particular unit time how much of growth has taken place, that will be a absolute growth. So comparison of total growth per unit time. So comparing it with the total growth, how much growth was there before and after a period of time how much growth has taken place. So by comparing with the initial growth and the final growth, we will be able to say how much growth has taken place in the living organism. So that will be your absolute growth, just simple phenomenon in a unit time, how much growth has taken place. Earlier how much it was and after a period of time how much of growth has taken place. So that is the absolute growth, that is comparison of total growth, that is final growth per unit time. Per unit time is the absolute growth. For example, this is the leaf. Earlier the leaf was, this is A, at the starting, initial, that is at the starting, that is the length of the leaf was 5 centimeter square, the size we can say. At the starting, at initial time, the size of the leaf was 5 centimeter square. Now after a unit time, the size has increased from 5 centimeters to 10 centimeter square. This was the original size at the starting. Now it has grown and attained this size. This is the final size. And when we measure this size, here it will be 10 centimeters. Initial it was 5 centimeter, after a period of time it is 10 centimeter. So when we compare it with the initial growth and the final growth per unit time, when it was initially it was 5 centimeters, in a month's time how much growth has taken place. For example, if we take time in a month, 1 month time I am taking. So earlier it was 5 centimeters. After 1 month, the size has become 10 centimeter square. So in 1 month how much growth it has shown? 5 centimeters. Earlier it was 5, now it is 10. So in that time, in that 1 month, how much growth has been shown? 5 centimeters square. So that is comparison of total growth, that is 10 with the unit time in 1 month. From its initial to after 1 month, how much growth has taken place. That will be your absolute growth. This is case 1. You take in another case, we will take another case. Here this is also a leaf. At the starting initial, the size was 50 centimeter square. The size was 15 centimeter square. You just say after 1 month, the time is 1 month. After 1 month, the size has changed. That is the leaf has grown, expanded, and now the size of leaf is 55 centimeter square. This is the final size. This was the initial size. Initially it was 50 centimeter square. After 1 month, it has shown the growth, and now it is measured as 55 centimeter square. How much increase in size has taken place? In over a month, again it was 50, now it is 55. How much centimeters has been increased? 5 centimeters has been increased. In both the cases, in this case also 5 centimeter was increased. Earlier it was 5 centimeter, now it is 10 centimeters. In the same case, in the second case also, earlier it was 50 centimeter, now it is 55 centimeter. Here also 5 centimeter increase is seen. Both here also 1 month, here also the time is 1 month. So increase is also the same. Here is also 5 centimeter per 1 month. Here also 5 centimeter per 1 month. In both the cases, the size increase in the size is 5 centimeter square. So this will be a absolute growth. In this, the absolute growth is 5 centimeter, the total growth. Afterwards, how much is the size? It is 10 centimeter. So this 5 centimeter, how much increase we have seen? 5 centimeter. Here we have seen also 5 centimeter increase in size. So this is your absolute growth. How much of growth in how much of time, and that is in a particular time. Now coming to this relative growth. Coming to this relative growth. In comparison with initial size. In comparison with initial size, how much growth has taken place? Here it was just how much growth has taken place in unit time. Now here the thing is how much of growth has taken place in comparison with initial size. From the initial size, how much more growth has taken place? Here is in reference to initial size. In respect to, that is in respect or in reference to initial size. In reference to initial size. Here the rate of a given system, system in the sense any leaf, stem, root or whatever you take, the rate of given system per unit time. In 1 unit time, how much a system has shown growth in respect to, that is per unit time, expressed on common basis, that is per initial parameter. Per initial parameter. Here we are taking the parameter as increase in the size. So how much growth has taken place in the size of the leaf, in the size of the leaf in comparison with the initial size of the leaf. Here how much growth has taken place per unit time. Here how much growth has taken place per unit time with respect to initial size. With respect to initial size or the initial parameter, whatever you are taking as parameter. Size, matlab size can be taken, number of cells can be taken, volume can be taken. Initial parameter, parameter can be anything. So with reference, here it is in relative, in reference, in respect to the initial one, in respect to the initial size. So here in absolute growth we have seen in both the cases 5 centimeter was increase. In this case 1 also 5 centimeter was 5 centimeter square is the absolute growth. Here also 5 centimeter square is the absolute growth. Let us see in both these cases how is the relative growth. Absolute growth is 5 in both the cases, that is total growth. How much more it has grown? It is 5 centimeters. But now we will calculate the relative growth. We will calculate relative growth. In case 1, that is here in this you see, in case 1, initial size was 5 centimeters. Okay, initial size was 5 centimeter square. After 1 month you just take. So after 1 month the size is 10 centimeter square now. 10 centimeter square now. When we compare it with the initial size, it has shown 100% increase in size. From 10 it has changed to, from 5 it has changed to 10 centimeter square. That means with respect to the initial size, it is totally doubled. Initial size was 5 centimeter. Now the final size is 10 centimeter. It is totally doubled. That means 100% increase in size. With respect to initial size, this is 100% increase in the size, because it changed from 5 to 10. It is totally doubled. So with respect to 5 centimeter, now it is 10 centimeter now. So how much growth it has shown? It has shown 100% growth. It has shown 100% growth with respect to initial size. The same you see in case 2. In case 2, in the previous size was 50 centimeter. Initial size was 50 centimeter. Then after a month, now the final size is 55 centimeter. The final size is 55 centimeter. Here also there is increase in the size, but with relation to the initial size, there is only 10% increase in the size. From 50 it is going to only 55. So there is only 10% increase in the size. But here it is from 5 it is going to 10. It is doubled. The size is doubled. So here is 100% increase in size with respect to initial size. Here it is with respect to the initial size, it is only 10% increase. So this is the relative growth. This 100% is the relative growth. This 10% is the relative growth. Absolute growth, how much growth has been taken place? From 5 to 10 it is 5 centimeter. From 50 to 55 it is also 5 centimeter. Absolute growth at unit time, how much growth has taken place is just the absolute growth. In both the cases absolute growth is 5 centimeter per square. But when you compare it in relation with the initial one, so here the relative growth in the first case is 100% and the relative growth in the second case is only 10%. So relative growth can be measured. Same with how much of growth has taken place within a particular time, but with respect to the initial size, with respect to the initial parameter. That parameter can be size, that parameter can be length, that parameter can be weight, that parameter can be increase in number, any parameter. But we have to compare it, compare the final that is increase with the initial one. So with this we have finished this both absolute growth and the relative growth. In the next class we will see the conditions for the growth of the living organisms. Till now we have seen what is growth, And what are the characteristics of growth? That is, growth is nothing but irreversible and permanent increase in the size of the organism, and that increase in size of organism takes place with the increase in number of cells, and with the increase in number of cells the mass will also increase. Then we have seen the characteristics of growth, that is, growth is fundamental, growth is conspicuous, that is, which can be seen, and growth is indeterminate in plants, that is, unlimited. It is open type where every now and then new cells will be added to the plants. Then we have seen another characteristic, that is, growth is measurable. Growth is measurable. So, we have seen how to measure the growth with respect to different parameters. Cellular level also growth will be seen, protoplasmic growth, but we cannot see it. So, in order to see it, we use different parameters such as height, size, number of cells, or volume, or weight. So, these different parameters we can measure the growth. Then we have seen mathematically how we can calculate the growth rate by arithmetic growth rate and geometric growth rate. And then we also, today's class we have seen how to compare the quantitative, how quantitatively we can compare the difference in the growth of living organisms. That is, it can be by two ways, absolute growth and relative growth. In absolute growth, only how much of growth has taken place with respect to time. In relative growth, how much of growth has taken place with per unit time with respect to the initial parameter, whatever may be the parameter. So, this was about the that is absolute growth and the relative growth. In the next class, we will see what are the different conditions which are required for the growth of the plants.